Hello, hello. Oh my goodness gracious. That started faster than I thought it would. That was really fast. Holy cow. I just pressed the button and it just bam. Just was there. Holy cow. Okay. We're almost there. Let me just boot up one or two more things and we'll get going. Hello, hello. No IRL cam today. I am dying of sweat. Not even heat, just the raw amount of sweat. Enter. Okay, that's on, and we're good. Okay, so let me put up one more thing on my phone, and we'll get going here. We got a lot to talk about at the program here. We have a lot to talk about, because I did a lot of programming off stream, but let me just get a few things booted up. Boom, boom, boom. Okay, minimize, increase, go left, whoops. Increase, zoom, go to like here, zoom out, and go like, no, just grab it. Man, PNG viewer in Microsoft, let me tell you, there we go. Okay, there's that. Put that, okay. Can I just like alt click it? No, I can't even do that, huh? Okay. So Visual Studio, let's boot that up. Let me show you guys where we're kind of at with Wafshire. So I did do a lot off stream. Specifically, I finished entity components. There's one last thing I have to do, but we'll do that together here. Do I need an update? Later. Okay. So this is kind of what's going on here. Whoop. And then can I go up with this at all? There we go. Okay. That kind of works. Okay. So let me kind of walk you through this system we got going. In fact, before we do anything, I just quickly need to do this. Copy. Put that in the namespace area. We want these to be integers, so we're using a regular enum. Although, we'll talk about that. We got stuff we gotta do here. recording. I shouldn't be recording. Why was I pressing the record button? What the hell? Okay, so we got a lot going here. Let's talk about this one at a time before we do anything. Let's make sure it runs. It does not, because default contains no case labels. Switch statement contains a default, but no case. Oh, because I need to go data position. Whoops, my bad. Hold on. I gotta switch this real quick. Okay, so we'll talk about this one at a time here, but I just wanted to let you know kind of where we're at with things before we go on to systems, like right now. That's all data, and then this is all data now. Okay, we just wanted to scope in our enum there. Okay, so let me kind of walk you guys through what's going on here. Just make sure this is running. Okay, perfect. And no warnings. All right. This is how we are setting up entity components in our system. This is going to be simplified, but this works for now. So our program is going to have a bunch of structs called components. These components are all going to contain 1, 2, 3 variables at most that contain some amount of memory relating to what we need. So it could be a SDLF point for a precision point. It could be a color. It could be a float value, a Boolean value, whatever it may be. Okay. Okay. Now, in order for entities in this game to have a component, we are going to go pure, unadulterated ECS, like no inheritance whatsoever. Everything is an entity. A sound file is an entity. A sound effect, a UI, a player, bullet, everything is an entity, okay? Your game is set to League of Legends. Fuck my life, thank you. Hold on. F my life into pieces. This is a last resort. Suffocation ain't no breathing. How do I change my game? There we go. Okay, hold on. Thank you. Software development. Done. Thank you. Okay. So, what was I at? Oh, So we're going to have entities. Everything is an entity. So this is how we're going to set it up, okay? In order to add a component, and we're probably going to make this a lot simpler, but just for now, this is our tech debt. In order to add a component, you have to add a struct that contains the component type and like what it is and everything. Then you have to add it to the end of the enumerator. These are intended to be integers. A better way to do this would probably go like class enum int. That's probably a good way to do it. But for our purposes right now, a regular unscoped enumerator works just fine. Well, unscoped enum inside of a scope namespace, but we'll ignore that for a second. Gary, you don't need the export on all components since you're exporting the namespace. Based. So, perfect, right? There's our enumerators. Now, what's going on here? When you add a new component, this is n plus 1. N is the number of components. This is important to use later because this const is, we're going to use it a couple of times. Every component is going to have a map. A map is just a container that in order to find its elements, you have to give it a key. In this case, it's an integer. Oh, integer, wait, a key. Every entity, and we'll go over it when we get there, has a const int ID number. This ID will be unique to every instance of every entity, okay? So if you shoot out 5 fireballs, they're all gonna have separate IDs for reasons we'll talk about when we get to systems today, right? That is the key that we insert into any given map. But what's the point, right? The point is that now in memory, we have a container that contains every position value and puts them not exactly, but for layman's purposes, right next to each other, right? And it's more efficient that we have all of the velocities next to each other, all of the health values next to each other, that kind of thing, right? And these are all keyed by the integer of the entity. Now, cool, right? A bunch of maps. What do we do with them, right? Now, we have, before we get to our entities, we're going to have an entity manager. This manager is going to keep track of a few things. It's going to have the total number of entities in the whole program, everything, every unique number. Why a map instead of an unordered map? Because we want the map to not be an unordered map because we're going to be iterating through it are we iterating through it? We'll talk about it when we get to systems, but I am 99% sure we do not want an unordered map. M total entities. This, by the way, is going to be the same number we give as an ID value to our entities when we make them. So every time we make an entity, we increase it by 1, but we'll go over that method in a second. Then we have a standard vector that contains a shared pointer of object entity. I understand shared pointers are not the most efficient use right now, but it makes things really easy. You can iterate an unordered map. It's just not in order. Okay. And then this will be called M entities. This, by the way, is just every entity. That's all it is. We just have a vector of every entity. So as we develop systems, what we're going to be doing is iterating through this list of entities. Sometimes, if we need every entity, right? But it's just nice to have a vector that contains all of them because it's more useful than you think. Now, we're going to have a second vector that also contains a shared pointer entity called M to add. We'll go over that in a second. Just keep that in mind. It's another thing that contains the same kind of entity. Then we have another map that contains as a key, a string, and a vector shared pointer entity is it like its type, or what it contains in that spot. And we're going to call this entity map. Now, what is going on here? Why do we have a map that has a vector of shared pointer entities in every spot? Well, this is how we're going to do our tag system. So a string is just like, it's like this is a bullet, or this is an enemy, or this is player, or this is sound effect, whatever the string may be. This standard string is going to be the key. So every entity that I want as a designer to be of type bullet can be stored with its own key on this map. So whenever I have a system that's like, let's say the player has like a bomb that removes all bullets on screen. Well, what we would do is when the bomb detonates, we iterate through every string type bullet in this vector, and we just do something to it, get rid of its XY value or whatever it is, kill the bullet, right? Like set the Boolean is alive to false. So that's kind of how we're going to handle tags, which are going to be so helpful. We then can instantiate this entity manager with no values, so we can later on just go entity manager nanny or whatever we call it, right? Now, what's next? We have our update function, so our update method. Okay, okay, before we talk about that, let's talk about add entity. We'll talk about why in a second we need a separate update method, which gets a little complicated. So whenever we want to add an entity to the game, we want to create something. All we need to do is call add entity from the entity manager and just give it a tag. That's all we want, right? Just give it a tag or whatever we call it, right? Then it's going to create an entity using a make shared entity function. So this is make shared is the equivalent of new entity. It's the same thing, except instead of having to later remember to call delete entity or whatever context we put it in, shared pointer takes care of the delete part. So this reads as new entity. That's all make shared does, just handles the memory management or ownership, which inadvertently takes care of memory management. And then this entity will be of object type. In order to instantiate an entity, which we'll talk about in a second, we have to give it an integer ID number and a tag, which we identify here. So add entity bullet, right? Bullet, total entities, which is currently 0, and then we add to it. Why the add after? It's because we want it to be the current number, and then we add 1 after it. If we did this, M total entities is currently 0. This entity would be made with, increase this number. It's now 1. That is the number we're going to pass through. But if we do this, give it 0 and then add 1 to total entities. And then we give it the tag of whatever we want. Then we add it to we push back on the vector that is called a to add. Now, why did we do that? Okay, I forget the exact verbiage here. There's language in programming that's pretty infamous. It's where you iterate through a vector, but you're also changing the values of the vector at the same time, which is kind of like a no-no. The idea here is if we iterate through, let's say our player, or let's say the enemy shoots a bullet, okay? Enemy shoots a bullet. When does that bullet in game logic, not in when you see it on the screen, but in game logic, when should that bullet be rendered in game logic? You could make the mistake of thinking, okay, when the player shoots, just spawn the bullet instantly, but that's not what you should do. What you should do is have an update function that will, at the beginning of every frame, spawn all the entities that need to be spawned. And then, Gary, don't return shared pointers by reference. Wait, what? I can't do this? Why not? Wait, what's bad about this? It messes with the reference counting? So I should do that? Don't I want it to be by reference? Because this just makes a copy, doesn't it? Because if I do this, it'll make the entity object, push back on the vector, and then return. But because we made it a shared pointer, it doesn't delete the memory, it just goes onto the vector. But I want to create a reference to it, don't I? Copies are cheap for shared pointers. It could delete it. Oh. Okay. Cool. Well, I'll trust you. You guys know more than I do. In any case, this update function, what does it do? So, we are going to remove and add entities at the beginning of every frame. So we have a ranged for loop here called auto. Auto being standard vector, standard shared pointer, entity, iterator, value type. It's a very standard. Yeah. It's a very long value, but that's what auto's for. Colon, because it's a ranged for loop, meaning iterate through the entire thing. M to at, which is that vector of shared pointer entities. We then push back on the M entities vector, the one that actually contains every entity in the game. And on this entity map, we take that entity's tag, which is that standard string value. That's going to be the key. So if it's a type bullet, if it's a type enemy, if it's a type sound effect, music, whatever, it'll go to that vector of entities, and then we'll push back on that value. And there you go. Now it exists in the game world, and it doesn't mess up logic anywhere. And then we clear the vector of 2 adds. So we free up the memory, right? We don't need the vector to exist outside of this moment in the frame. Now, or have any values at this moment in the frame. Now, this is what we're going to change right now, because I know a better way to do this after some research, okay? Currently, it's int t index equals 0. Then we iterate through m entities. If this entity of that spot in m entities, that is to say, all entities, is alive equals false, because there's a Boolean value of should this thing be killed or not. If it's false, as in to be killed, then take that m entities at key level t index, which is that spot in the vector, reset. Reset, I believe, remove the entity from the vector and shift everything up, question mark? We'll have to check that. And then we're having trouble iterating through. So there's a better way to do this. What we could do, for example, is this. I didn't even know you could do this. Int, is it auto or int? Int t index equals 0, semicolon. This works. This is valid syntax. I didn't even know you could do that. This must be like a super new feature. In a ranged for loop, you can actually give an index number in the for loop. Isn't that fucking cool? And it still works fine. Wow. And if statements? What? You can do the initialization in it. Oh, and if statements, you can do the initialization in it. Yeah, yeah, ranged for loops, pretty fucking cool. I didn't know you could do that. In any case, it helps keeping indexes better. My question is, and maybe you know this, coder at Paradise, do I have to add the ++ index at the end of every loop? Or does by putting this here automatically increment the t index value? Why do I call this t index? I don't know why. Maybe I should call this entity index. Okay, so we need to fix this though. This isn't done. If this value of this m entities is alive equals false, then what happens? I think you do just because of how you are doing it. Okay. If this is false, then in m entities at spot e index reset. Is that the best way to do this? I'm worried. Reset. What does reset do? It depends. I think reset just sets the value to like 0, right? Replaces the managed shared pointer with an object pointed to by pointer. Optional deleter can be supplied, which is later used to destroy the new object. So I'm just removing the shared pointer, right? Is reset not the right value to use here? basically I'm trying, okay, so in that spot in the vector, I have to be really careful. No, you are setting it to null pointer. Oh, so I should say that value is equal to null pointer. Is that what I should be doing? So let's say we have 10 entities, right? And entity 5 is the only value set to reduce. So 0, spot entity is 0. Okay, don't is alive. Okay, 1, 2, 3, 4, 5. Well, 4 in this case. So on iterator 4, E index is currently 4. 4 is alive equals false. This rings true. At M entities, spot 4, which is the 5th element, make it equal null pointer. This doesn't delete the shared pointer though, does it? Because there are other things currently using the memory. Null pointer and reset is the same thing. Oh, is it? Ooh, I like reset more. It makes it more clear about what I want. Okay, now, shared pointers are deleted when the last reference is deleted. Okay, currently, I think, okay, we'll talk about this in a second because clearly that's might change. But ignoring that, what's highlighted there, if I remove that from the entity map, it should be deleted. That's the only two places it should be, is the entity map with its tag and the entity vector. In any case, int e index equals 0, iterate through entities, spot 4 is reset. Now, the entity map is different. I need the string that it is, which is here. And then at that string, we need access to the vector. And on that vector is entity map. So how do I access the vector in that spot? Do I just erase? But that doesn't work. E index? Is that the value? Or do I just go erase? This is where I was confused because normally in like a map, you would just go like erase or whatever, right? And just be happy or whatever it is, right? But it's a vector in a map where I'm iterating through the vector. Wait. Do I need a separate iterator? Is that what's going on? So do I need a separate for int, oops. Wait, hold on. Here. For int index, for entity index, 0, auto e, m, entity map. Do I need a separate like loop? No, this is dumb. No. I don't need a separate loop for this because I'm, yeah, no, that's dumb because maps, I don't have like a bunch of things to do there. Yeah, it is m entity map bracket. It must be m tag, right? I just don't know how to access the vector. You need an iterator so you could do the vector dot begin plus index. Oh, that's smart. Well, E is the iterator, right? That's what auto E is it's explicitly the iterator value type, whatever. Don't you love combining C++ containers with pointers? This is where my brain runs out of RAM for this shit. Oh, it's I don't know. I don't think it's that complicated. Like, I would argue it's more of a syntax thing right now. I understand conceptually what's going on. Katie Bug, hello, welcome to the difficult programming stream. Is there anyone here who doesn't understand, besides people who don't program? Is there anyone here like conceptually doesn't understand like what's going on here? I think everybody does. It's just syntax, right? Rip, I'll be of no help. It's okay, Katie Bug. Yeah. No, I'm excited. Katybug, can't wait to meet ya. I want to see how short you are. Ha! No, the iterator of the vector in the entity map. So you're saying that I need another iterator in the index loop? So I need another ranged for loop? So I don't need another index. I need auto E2 M entity map bracket E M tag. And that's it, because now this is iterating through the vector. So E2 dot, no, E2 bracket E index. Shit. Dot. I pressed Alt. Dot. This is wrong. No operand matches shared pointer type. So this is an iterator through this. Oh, it's already the iterator. Okay. So now, is this right? Fun fact, I tried to learn programming once. Ooh, I'm fun-sized 5'2". Hot dang, you're a shorty? You're shorty in a good way. Hey, I don't hate, I appreciate. If it makes you feel better, I'm like 5'9" on a good day, okay? You get the iterator from begin. You don't need a loop? What? What do you mean I don't need a loop? Wait, I don't need a loop for this? You need the iterator from begin. So M entity map. This is why I couldn't do this on my own. Okay, M entity map E M tag. That is the key for the vector we're on. Dot begin plus E index. Now I understand this is not a complete statement, but this is what I want, right? So I'm taking the first value of that entity map. I am then adding the integer value to this is, I'm not doing something right. Do I need a standard iterator? A short stack of pancakes I am. Yeah, I'm 5'9" on a good day. What do you guys got? Main unordered map. Yeah, no, we're using a map. Vector int a, int idx equals 5, index equals 5, auto vec equals a string, vec erase, vec begin. Oh! So we need erase m entity map bracket e forward m tag dot begin plus e index. That's what I had to do? Wow, that is so unnecessarily verbose. I mean, I guess it is necessarily verbose. Okay, I never would have figured that out on my own. Thank you. Okay, geez. Yeah, that's where I got stuck and I was like, fuck it. This is why the vec variable was there, to make it shorter. Ah. Okay, I got you. I understand now what is going on. Yeah, I wouldn't have been able to do that. I knew I had to call erase, but I didn't realize this was what I had to do. I get it, but like when I read this, I thought it was like you take the beginning value and you add e index to that value, but I guess you don't know what it's actually putting in that spot. Well, I guess it's all shared pointer entities, but whatever. Okay, all right, that's done then. We're done with this. The update entity thing, that's finished. We still need to get entities, either through the entire entity vector or the entire... Do I actually need that? Oh yeah, I do need that because we're gonna make systems in a second, and systems need access to these vectors. But I want them to be private because I don't want you to have access to them. All I want you to have access to is update, add entity, And then you need to be able to get this list. So I thought you would return the entire vector by reference. How is school going, by the way? Corky says hi. School's going great. Oh, you guys want to see the results of my newest test? Oh, get this. Look at this. Look at this. Oh, whatever. We'll screw it up. Look at this. Oh, shit. Oh, shit. Chat, just call me. Just call me. Just give me this degree now, baby. I am ready for it, okay? Your update loop is gonna crash after removing an entity. Ooh, we'll check that out in a second. Anyway, yeah, this degree, easy peasy. 97%. I spit on that like I spit on my mouse pad. Okay. Grab this. Okay, so this update loop is gonna crash after removing an entity. Why? So we index this. We then have an M entities vector. If that entity is alive equals false, reset that spot in M entities and erase the value from this map using the key. And then iterate through the rest. Is there something I'm missing? You delete the shared pointer, but not remove it from your map. So if we'll eventually access null pointer and crash. Your order of operations is wrong. What? You delete the shared pointer, but not remove it from your map. Oh, you're right. I didn't even think about that. You are correct, good sirs. Okay, you're right. I now see what you're... No, I don't see what you're saying. No, I don't understand. Reset is not a delete shared pointer function, right? That's not what that means. What this means is that you're setting this value in the vector to 0, but the entity e-index, sorry, the entity that was at that. Wait, am I deleting the shared pointer by calling reset? Like no matter who owns it, I'm just deleting it? I thought the whole point of a shared pointer was that it exists until nothing owns it. No, it might not crash since E is a copy of shared pointer. Yeah, it's a shared pointer entity, right? Okay, I'll be back. Gotta go date some 2D husbands. Cute! Have fun! I know programming's not for everyone, Katie Bug, but hey, this video game's gonna be awesome. So what you guys are saying is that this should go there. That's what you're saying. So erase it from the entity map first using the tag as a key and then reset the shared pointer. And at that point, nothing should own it. My point is that M entities will have a null pointer in it and your loop iterates over that and tries to access is alive on a null pointer object. M entities, this vector, will have a null pointer in it and the loop iterates over that. Oh, I see what you're saying. So that's not the problem. The problem is, oh, we're not shifting up the vector. Oh, M entities dot. How do we? Wait. No, that's right. Yeah, no, this is fine. I'm okay with moving everything up. That shouldn't make a difference because we're not using the ID of the thing or anything. We're just going where it's at in the vector. How do I push everything up? This is C end, C clear. That's, or C end and C begin. That's const, right? Back, assign range. Is it get allocator? Pop back? No. Resize? There's something I'm calling here to resize the vector. You are right. I do need to do this. My point is that M entities will have a null pointer in it. Yeah, so if we call it twice, it's gonna crash the program. Resize won't work? Yeah, I figured that out. Okay, hold on. How to shrink a vector to size. Vector shrink to fit is a built-in function in the STL which reduces the capacity of a container to fit its size and destroys all elements beyond the capacity. No, that's not it, because that wouldn't solve the problem. How to not shrink a vector. Since a shared pointer with a null pointer is still a shared pointer. Well, hold on, just to be careful. Okay, just so we're super clear, okay? This does indeed set it to null pointer, but once this map is set to, you know, erase the value from the vector in that map with the tag as a key, once that happens, the shared pointer itself is freed from memory. So is this vector value in this spot, is that actually a null pointer? The shared pointer still exists in M entities? Wait, I thought reset was to explicitly make it so that you don't have to manage the memory. I thought, wait, how do I remove it then? Oh God, wait, is it M place? No, M place is insertion, right? Or remove, I don't remember. Wait, hold on, M entities, E index, dot. No, we don't want E index. We just want the entire vector, right? Just subscribed, D. What happened? Oh, on YouTube. Oh, hi, D on YouTube. Wow, YouTube subscriptions. Holy cow. Hi, thank you for following on YouTube. I haven't seen you chat yet, but hello, I'm paying attention. I got you, fam. So you're saying in this M entities dot index value, we need to swap, use count, reset. This is just getting the specific element, that thing. So we need to say, this is just an integer value. That's all this is. And then the entire thing is an entity. So what we should do is at this spot, erase? No, erase doesn't work because it's pointing to the shared pointer. So it should be like erase, iterator, erase, vector, shared pointer, entity. No, that doesn't work, right? I wonder how you call this. Man, putting maps and vectors are so fucking complicated. The same pattern as with map? What? Really? Erase, using value, M entities bracket, or no, dot begin plus E index. Like that? What? No fucking shot. What's the difference between that and M entities bracket E index dot erase? What's the difference between these two? Why does the second one not work? And now you have undefined behavior and broken code versus an accessor. Okay. Okay. Oh God. Am I just going about this all wrong? Am I just like, is it the shared pointers that are fucking me up? Or is it, not understanding removing something from a vector? Brackets are an accessor. Like it's Excelsior? You can't change a vector with the type of the loop you're using. You can't change the vector with the type of loop you are using. This is undefined behavior. You can't change the vector, this, with the type of loop you're using. I don't understand. Are you saying like this should happen after we iterate through everything and then resize? Oh, and then resize. Oh my God, I'm so dumb. Oh, Jesus. Oh, I understand what you're saying. Okay, I understand what you're saying. What's happening is that we're iterating through M entities. By erasing this value and moving everything up, it's kind of fucking everything up. Oh, how do we fix this? Iterators get invalidated when the vector changes, which means the next iteration will erase will be undefined behavior. Iterators get invalidated. Yeah. So now here's the problem. Let's go outside. So like this is what happens here. So it's like the same thing as this, right? Where we clear M to add after we're done iterating through the entire thing. But if I called it in the middle here, obviously there would be issues. E will not be the correct value after removal. Gotcha. Okay. So now, obviously we can't use this, but we call it down here outside of the iteration. Erase returns a new iterator, so all you need to do is write an old school loop using iterators. Nah, we can do this easier. Okay, so we're gonna call erase outside of this value. But the problem is there a better value than erase? Is there a way? Because there's a very real chance that when we iterate through this whole M entities vector, that we end up with multiple pointers that are null pointers, right? Multiple iterators that are null pointer, and it erases and it resets it and it sets it to null pointer. Okay, good. Now, here's what I want. I want to be able to take every null pointer out of M entities in this function and shrink it down to size. Does that make sense? So that we don't iterate through null pointers again. Nope, erase is the only way. Is it really? Erase if? Ooh, wait, what's erase if? Erase underscore if. Has no member erase if. Ah, get fucked. Okay. So we have to call erase whenever we hit a null pointer. It's a free function in standard, not on vector. Oh. Well, let's see here. Standard erase if vector erases all elements that compare to value from a container equivalent to this. Okay, here's my worry. I understand what you're doing here. So can we do something like auto it equals standard remove? That's like the original value, right? So what we want is remove if standard erase 3. Okay, so we want standard erase if we want the value of M entities, comma, and then do I just go null pointer? Does that just work? Wait, is that all I have to do? It doesn't compile. There's some error here. Term does not evaluate to a function taking 1 arguments. Remove if. You need a lambda. What? Oh god, it all comes back to lambdas, doesn't it? Okay, what do they do here? A vector of characters called CNT count to 10. Standard iota. Oh my god, an iota. Begin, end, 0. Print the entire thing. Erase the value 3. Erase if. Okay, so it is a lambda. Auto erased is equal to standard erase if. Okay, then we have our container, and then he has a lambda, empty brackets, character X, I'm assuming because this is value type character, and then return a value. Erase all even numbers. So he's just returning an even number. So what I could do is instead of saying null pointer, I could say empty brackets, standard shared pointer type entity, entity, and that would be the parameter, and then the curly braces would be null pointer. Return null pointer? Like that? I mean, that looks ugly as fuck, but I mean, it might be what we have to do. You would do something like this. Erase if vector bracket auto v return v equals pointer. Also, I like that arrow more. Thank you. Expecting a type specifier. Never mind. Man, lambda expressions, let me tell you. Okay, so that's our lambda. So that's it. It's just, it iterates through the vector. If the value returns null pointer, erase the value. But be aware, you're going to iterate the entire vector twice if you do it like that. What? You need a comparison, not return null pointer. Isn't... So, like, you're saying, like, if something, or maybe like x equals y or something, right? If statement, return null pointer colon something. Is that the kind of syntax we're talking about here? I'm sorry, lambdas, I am convinced lambdas sounds like the most wonderful thing, but I swear to God, I learn something new every time I do it. The shared pointer is a function parameter. It needs a name, and then you compare against it? What? Auto erased is equal to this value. So auto, we'll just copy here. Auto erased is equal to this value that's not done. He goes return x is equal to the character 0. Mod 2 is exactly equal to 0. Okay, so it's an even number. If this is an even, return an even number, right? Return 0. Standard vector complex double numbers 22424842. If def standard erase nums, print line. Okay. Jesus. What? What's the point of making the object? What is this? Standard shared pointer. What? It needs a name and then you compare against it? So what does he do here? Auto erased is equal to standard erase if the container, and then a lambda expression taking in character. Oh, character X. This needs to be X. Oh, okay, E. Okay, now that's the value we're going to be taking in. Oh, shit. So you're saying if, okay, so like if E is equal to null pointer, return null pointer. Is that what we're doing here? I understand more of what you're saying. No, it's still not the syntax. We're getting closer though, I think. We're getting closer. I don't know what the syntax is. Shared pointer, entity, return entity is equal to null pointer. What? Return E equals null pointer. That's the syntax? Also, it doesn't work. Oh, yes, it does. No, it doesn't. Expected and expression. No, it doesn't work. No closing brackets? Oh, you're right. Thank you. Okay, there you go. Wow, that was so complicated. The lambda returns a bool, true equals delete, and false equals do not delete. Gotcha. So what we're saying is for every object in M entities, the vector, do this test. This entity in that spot in the vector, if it returns null pointer, erase, because it's an erase if the statement is true. Okay, Jesus, lambdas are so complicated. Like, I wish the syntax was lambda, like they actually use the word lambda. Lambda E parentheses null pointer or something like that would be so sweet, and they won't do it because that's too easy. Damn. Holy shit. What a function. It's a shared pointer that messes with things. Yeah. Also take the E as a reference. You don't want a copy here. Oh, you're right. So it's auto, or not auto, just by reference. So chat, I have a question. What is this variable? Why do I want this to exist? Do I even need this to exist? Can I just do that? I think this is all I want, right? So we're done. We're done with this update function forever, right? Thank you, what the fuck, blub. If you really want, you take it by const reference. I mean, sure. I mean, we probably should. In fact, a lot of these can be const. I'm really bad about implementing const. It's something I'm not good at. Although I say as I have const everywhere. It's something I'm still trying to get used to the idea of, is just always const everything. Okay, we're done with that. Fuck that function. Jesus Christ. I thought I got stuck at the map. I didn't realize I would get stuck at like erasing null pointers from a vector. Jesus. What did you guys do before lambdas? Was it just a simple loop? Like that ugly ass C loop? So it's like for int I equals 0. I plus plus. Sorry, I make fun of C. Function pointers? Oh, so like, oh, no. I know what you're talking about. Yeah. You make a pointer that calls a function when you point to it. So it's easier to use as a parameter. Right. I know that. Also, I learned a new phrase. Oh, I've never used this before. I didn't even know this was a thing. Hold on, where's a function? What is it's no except, right? Okay, no except is kind of based. I didn't realize this was even like a thing until I read it today. I'm like, what the fuck? I'm sorry, maybe I'm just dumb. I never knew no except was like a thing you could actually do. Look at this, hold on, let's bring up a resource here. Can I get, whatever. Hold on. C++, no except. Look at this thing. Fucking OP. The no except operator performs a compile time check that returns true if an expression is declared to not throw any exceptions. Basically, if you call a function and you know it'll never throw back, meaning that there's no, as far as I know, that means that you will only ever have one thing happen with like no exceptions, right? There's no like, oh, person entered an integer that's too high, throw an error or something, right? No except is like, okay, compiler, don't worry about like keeping room in machine code for like error exceptions. Just it does what it does, right? Which is interesting. I don't know when we're going to use that, but I mean, it's pretty based, right? I'm so used to typing these. I'm so used to typing these days. Yeah. Struct with a call operator. That's exactly what a Lambda does behind the scenes. Well, I think that's pretty dang cool. Well, you learn something every day. And today we learned a little bit more about Lambdas and how to capture whatever. I still don't know what the brackets here are for. They look kind of dumb, but I don't know. They're there for a reason. Listen, I don't question the committee, okay? The C++ committee is based, all right? What are we doing next? Capture group, it has its purpose, but it's not needed here. Okay. We are going to get entities from either a string, meaning from the map, or just from the regular vector. Now, how do we do this? We return it by copy, right? Basically, I want systems to be able to call, you know, get entities from this entity manager. And the reason why is because I want these to be private. I don't want you to have easy access to them, or at least to be able to add to them directly. But I do want to think, okay, you want to get entities to iterate through them. We would toss back a referenced value to this vector, right? I think that's what that means, right? Yes. Okay, so all we would do is just return M entities. And that's it, right? And then here it would be a little more complicated. It would be return M entity map, and the key is tag. And that returns a vector because vectors are at every keyed location on the map. Okay. Is it that easy? You need to error check that? But this? Ooh, that's a good question because I don't do error checking that often. How would this, why does this need error checked? What's the error check? We're just returning a vector, right? The clean way would be to have a function with a callback parameter so you don't leak the vector into the outside. The clean way would be to have a function with a callback parameter so you don't leak the vector to the outside. What do you mean by that? I'm thinking out loud. Don't actually answer that. Let me think. I'm a computer science student, a very new computer science student, okay? A clean way would be to have a function, so one of these guys, with a callback parameter. I don't know what that means. I know what parameter is, but I don't know what you mean by callback parameter. So you don't leak the vector to the outside. So you don't give this vector, which is a private vector, to like everyone else in the world. I wish there was a way in C++ to tell, like if I return a vector somewhere, I wish there was a way to be like, okay, its scope will only be where the function is called. And if it goes anywhere else, nobody has access to it. Something like that. That'd be kind of cool. And your function does the loop and calls the callback for each entity. I don't know if I want that, right? Because what I'm imagining is that later when we call like our, you know, physics, like system physics or something like that. Ooh, we can't call it systems. S physics. Whenever we have like that class, right? Or that systems function, what we would do is whatever there. What we would do is we would then ask like, okay, well now get entities so we can, so like we'll say list is equal to evec is equal to entity manager dot get entities parentheses, something like that. And then we would have like for auto e equals, you know, evec And then you would go through that way, right? That's what I'm imagining we're gonna do for a lot of systems. Also, is it wise to call it get entities and then get entities with a tag? I shouldn't call it that, right? Get entities with tag. That's what we'll call it. And then we'll return like bullet or something. And your function does the loop. You need to error check the entity map accessor. It will crash if it doesn't exist in the map. Oh. Oh, you're right. Ooh, that's complicated. But in any case, I think I do want to return the whole vector though. The cleanest way would be entity managers dot iterate entities lambda expression. Do system stuff. Whoa, that's kind of cool. Oh, I see what you're doing. So you're saying that don't do this. Instead, do entity manager dot iterate entities. So that would be the function. And then as part of it, you would take in the lambda expression. So you would be only returning the values that actually successfully meet the criteria. So bracket, auto reference entity, E, and then curly brace do system stuff. So in other words, if this entity manager dot iterate entities, if I'm assuming it's all entities, not just with a tag, but if that's the case, then if E ever runs successful, then do the system stuff. So it would be like E dot position. No, that's a lie. No. Oh God, hold on. We got to be careful. This is more complicated than you guys think. You guys are doing this like object-oriented programming. You got to be a little careful because our entities don't actually contain the values of like position and velocity and stuff like that, right? So systems don't necessarily interact directly with entities, although they kind of do. Basically, once a system, if an entity is part of like the bullet map, right? The vector in the map that's tagged as bullets, right? If it's true, it's going to have a bit set, and this bit set is operating like flags. It just asks, does it have this component? We haven't even touched this yet, but basically we have a switch statement saying like, okay, you want to add a component, if it, whatever, and then give it the component, whatever, right? And then it exists, and then we flip that bit. So once you have access to the entity, once a system has access to an entity, all it's going to do is just ask, does it have this very specific bit set? So, or not, this bit set in the bit set to true, then okay, do something to it, but it needs to know it has the component. So I'm worried we're going to get like this entity manager thing, or this iterate entity thing with the lambda expression. And then we go from there, and then we iterate through the bit set, and then we do system stuff to it. And that's going to get so deep so quickly. You can make an overload that takes the tag as the first parameter. Yeah, I know what you're saying. We won't do an overload though. All right, let's just do it this way. Let's just open up access to the vector with an understanding that I'm making the game and nobody else. Now, I understand that means, well, then do whatever the fuck you want, and it's not the correct way, and it's not the cleanest way. I understand that, but I'm also a sucky programmer, so we're still learning. I understand the feedback there, and that this should change if I was a better programmer, but I feel like every time I type a lambda out, it's a journey, and I don't think I'm at the skill level where if I ever have to use a lambda for something, there's not a cleaner way for a new programmer to do it. Anyway, all that is to say, this will be fine for now, but wouldn't be that hard to fix later. A little bit of a refactor, you know? Okay. Now, let's imagine for a moment that's done. Is there anything else we need to do? We haven't talked about the actual entity yet. I guess we could do that before we go on to make our first rendering system. So what is an entity? All this entity manager stuff, but what does an entity actually do? We have these are our private values, right? Const int MID equals 0. So if it doesn't have an ID given for whatever reason, if it ever happens, it'll default to 0. If it's always going to have a tag as well, but the standard string tag will default to needs tag. And we could do something where like we iterate through all of the tags in a, well, no, I guess it's not too easy, but we could definitely check if there's anything in the map of vectors with tags. If there's any entity with a needs tag issue, then, or if there's any entities in that map with the key needs tag, then okay, we screwed up somewhere. We didn't give something the correct value or something. Bool M is alive, true. Basically, every entity we create is going to default to being alive, meaning don't cull it. If this is ever false, then okay, now we're ready to cull, we delete it, but we handled that with the entity manager, right? Then we have a bit set containing or of length number of components, which is a constant integer value. And then we call it M has component. This is just a flag, right? This is just, do you have the component value associated with the entity? Something may be a bullet, but you know, does it have a sprite? Is it an invisible bullet? You know, stuff like that, right? Well, the rendering system to render something onto the screen as an image cares if you have a sprite. So it may be a bullet and it may like have an XY value and a bounding rec and all that stuff, right? But if it doesn't have an image to render, that component value, that bit is going to be turned off. And so the system doesn't even worry about this entity to render, you know? And then we claim a friend in the entity manager. So it's the only class that can have access to this entity's private values like MID and stuff. Because it's the only thing in the entire program that's ever going to need access to these private values. And I don't want to have to delete functions later. We then have two constructors here. One constructor is the ID number and the tag for the, as a constructor. Then we have an empty constructor. I think I have to have this there. I think that actually needs to be there because we're doing a lot of container stuff. And I think if we have only this line and not this, there are issues with the containers. I think that's why we have it there. Okay, this is where it gets... I understand this is not good. Okay, let me explain why these switch statements are here. I understand this is not the cleanest way to do this. Okay, I am very aware. I have thought a lot about this. I don't know a cleaner way to do it, but there must be, okay? How do we add a component in the program, okay? It's not enough to just flip the value. We have to actually tell, hey, this map of positions do something, right? So here's what we do. We take in, we want to add component, const int component, right? The int being this, this enumerator, which will be accessed via the main game loop and everything. So if we want to ever like, okay, we want to make a bullet invulnerable. Nothing can hit it, nothing can kill it. It'll just do its thing. Well, then we'll remove or not give the component of health or something. Inheritance is the cleaner way. But this is ECS. Think of the concurrency, all right? Let's say we have an item that lets us mind control the nearest enemy, right? So we give it add component controllable, meaning that the player controls them as well. And then the systems associated with that will automatically account for that. So controllable. If it already in the bit, this is the bit set. If that bit set with that value is equal to true already, meaning it already has the component, just return out of it. Don't even worry about it. But it can be a tool for modularity. Oh, that's the point, baby. This is gonna be the most modular thing in the world. Inheritance is far away from being clean in game programming. Well, the good news is, chat, here's the good news, okay? Before we continue, just so we're clear, once we have this whole system set up for entity and components, all we have to do is just add components. Everything takes care of itself, right? Everything. And it's so beautiful, okay? It's so nice, right? If I ever wanted to add a component for damage type lightning, I would just add the struct, add it to the enumerator value, create the map, add it to the switch statements, and we're done. All of the systems that care about damage would automatically, or want to even use it at all, would be somewhere else in the program, right? That's all we have to do. There's no new object, there's no new value, there's no inheritance. It's just add the component and just give it to whoever you need it to. And it's so nice and clean, but setting it up is a bitch, okay? So if it has the component already, just return, right? Then we have a switch statement, the component being an integer value, right? If the case is position, velocity, bounding rect, hurt box, whatever, damage type fire, moving, then take that map value using the key of the unique ID number for that entity, keeping in mind every single bullet and sound effect and everything is going to have its own unique instance of an ID. With that key, go to that value in that map and set it to 0. Now, I think, chat, I think what this means is that you instantiate the point, so you're creating it in memory. I think that's what that means. So we're initializing it to 0. It's creating the value. I don't exactly know how maps work at a very deep level. I think this is what we have to do if we want to actually have that component value exist. Now, this is why I say there must be a cleaner way to do this. Oh, and then at the very end, we just tell the component bit set to flip the value of that component value in that spot. So if it's like the 12th component, then hey, the 12th bit, flip it. So any system that cares about any entity having that bit flipped knows to interact with it, you know? There must be a better way to do this, you know? This looks so ugly. Now, here's what's even more complicated, okay? Removing the component. What if we want to take health as a component away from a bullet to make it invincible, or an enemy invincible, or like the player is damageable, gets turned off because, you know, it's doing like a force field or something, or like a shield? Well, we can remove a component very easily as well. We use a constant component, so the component you want to remove. We do the same thing. If the component is already removed, i.e. it's already false, just return out of it, don't even stress about it. This allows me to freely call remove and add component without worry if the entity even already has the component. We do the error checking in the function rather than the error checking, you know, in the game loop, right? If this has the component already, then Kobe, oh shit. Ugh. Now we do the same thing. We switch data positions dot erase that ID number. This is wrong. Based on what we learned down here with maps, I feel like this is wrong. Or maybe not. Basically, I'm taking this map and I'm erasing all values associated with that key. Is that correct? Depends on what you think is cleaner. Emplace would be a better choice because it's more efficient, but it can look rather ugly. I mean, if it's, you know, a better use of our stuff, I think this is fine for now. Well, isn't that the advice that people always tell me, is don't worry about performance until it matters? Don't optimize too early. I feel like that's one of those moments where we'll profile it and we'll see what's going on. Maybe we'll add maybe we'll make a program that just adds and removes like thousands of components a second. And if there's ever any issues, then we can fix it. Code Toil. Sorry, I don't know if this is like the third time I've said hi. I just see your comment. Hi. Okay. And then we erase the values and then we flip it, right? And then, okay. Now, killing the entity. This is where, okay, bear with me. Okay, I know this update value sets the values to 0 and null pointer and all that shit, right? But here's what I'm worried about. These maps are independent of these entities. if we give the key of 5 as an integer and a velocity value, and it's like 5, 5 is the velocity, the XY value is 5, 5, and we remove the entity, the actual 5, 5 in memory exists. It's not erased, it's not freed, right? So the idea is we would have a kill entity function where it would go through every single map and erase that ID number. Should I just put all this shit on a vector? Should I just like have a vector of all component maps and just push back them all on the vector and then just go through here and just iterate through? Maybe that's a better way to do it. And then if it has the component, reset and is alive. Basically, this is the bit set. We reset it to like all zeros and then set the alive to false. So whenever we want to kill the entity, this is just removing all the values from everywhere, resetting the bit set, is alive equals false, and then the update function we call every frame will erase it. I think that's how we're gonna do it. Again, there's probably a better way to do it. I understand, but it's ours. Cheap viewers on cut my life into pieces. This is my last resort. Suffocation. Sorry, you're banned. Okay, next. Systems. I think we're ready for a new module. Holy shit. It took so long, chat. It took so long. We're ready to start systems. What systems do we work on first, chat? What do you guys want to do? Rendering? I think we could do rendering first. I know how to do rendering because of SDL. It's not going to be that hard. What do we need in terms of bit sets? We need a position value. No, we need a bounding rect? Hurt box. Yeah, it's the bounding rect. So this bounding rect, here, SDL F rect. That's what we're going to use as our render box. Does the SDL renderer care about anything else? SDL renderer pointer renderer dot. No, SDL render copy EXF. No, render copy F. It's not EX because that's rotational value, right? Renderer, comma, and then it calls a bunch of other things. Yeah, okay, gotcha. What are we gonna render first? The player. The idea here is that our prototype is just gonna be the player, and it will be movable, and we're gonna go Mario 64 on this game, okay? Because it's a shoot 'em game, okay? You're doing a lot of shooting. I think what we've decided is that the player characters, because we're utilizing the art we commissioned for the other game that we haven't even released yet, the nymphs are going to be the player character choices. So you have like this chaos nymph here, you have shade nymph, that kind of stuff, right? And every nymph has going to have like its own, you know, it's like Binding of Isaac. Every Isaac is different slightly from the other. Every nymph is going to have its own little gimmick, right? But these are going to be the player characters. You're a nymph. Now, I think what's cool about that is we need to iterate very quickly what those feel like. This is the advantage of our systems thing where everything is so modular, is that the first thing we're going to be prototyping is player movement. That's the first thing we're going to do, which is pretty nice. So with player movement, we're going to go Mario 64 on it. We're going to basically not worry about enemies. We're not going to worry about like damage values. We're not going to worry about collision. All we're going to do is probably with WASD, but maybe just with the mouse and keyboard, we'll iterate. We're going to have movement and we're going to have shooting and we're going to see what feels good. Also maybe like zoom level, because I'm not sure how zoomed in I want the game to be. We'll see what feels good. And once we get to the point of where everything feels good, then we'll worry about like adding enemies, collision, but that's what we're rendering first. So with that being said, I think it's time we make a systems module. Now, a systems module must necessarily import components, right? We should call this components and entities, right? No, we'll just call them entities. Fuck it. Okay, beautiful. Let's make a new module. So project, add module, and we'll call this systems. So this is a module interface. It's going to be exporting module symptoms. We're going to be importing. I need the SDL.header. No, I don't need quotes, do I? And then we're going to import. Oh, fuck, I do. No, I don't. Import the standard library. Import. Fuck it. We'll just call it components. It's already called that. Import components, even though it is entities. Is there anything else I need here? Could not find module components. Shouldn't you? There we go. All right, so we have our systems module. How's it going? It's going great. We're about to render a player character on the screen, but it's going to take a bit to get the typing done. Hope you're doing well, Katie Bug. You stream? Have you been streaming lately? I haven't checked. I've been so busy with like school or everything. I feel like so irresponsible with like my VTubing like friends. 24 days ago. Or are you not saving your past broadcasts? No, I haven't been able to. Oh no. Well, I'm looking forward to it anyway. Okay, now, how are we going to be implementing systems? I can DM you an update though. Well, I know what's going on in your life, so I get it. I understand. Well, roughly. I know what's happening, not necessarily what's going on always. So let's export a system. Yes, because we have to call this system every frame, right? So we're gonna export auto render image is render images, render entity, render entities, render images. I guess we'll just call it render images. So anything that's an image, like has a picture value, just render that. Taken as a value. Nothing, right? Oh no, we need the entity manager. Entity manager value. Entity manager. E-man. We'll call it E-man. Is there any other value I'm gonna need here to iterate through all of the entities and then render whatever value we need? I don't think so. Because we already import components, so if I need access to any bit sets or structure or anything, I already have the logic there and the data, whatever. So I think that's all we're gonna need. I don't think we can go without it though. We are then returning a void value. I don't think we're gonna be returning. We could have a standard exception, I guess. But if it's a void, I always feel weird with standard exceptions. Corky Bug, sorry, I'm not even paying attention. Hi, Corky Bug. Oh, we got both sisters here. I don't want to self-advertise in your chat though. Feels weird, even though you just said I'm a streamer. Yeah, no, it's fine, Katie Bug. Advertise away. I don't care. Listen, I'm a double-digit Andy, okay? I have 11 viewers here right now, all right? You can talk about whatever you want. If anything, it's doing me a favor. Okay, so what do we do from here? We call auto evec is equal to eman dot get entities with a tag. No, we want all entities. Okay, now this is a vector that's of shared pointer entities. So now we're gonna make a for loop for auto value e is going through evec. Do this. Okay, so now we're iterating through every entity in the game. So now we have to go through a bit set. If data, no. If e dot has, oh shit. Wait, I'm doing something wrong. The entity is a shared pointer iterator from evec. So can't I go if e dot m has component equals, why is this not working? Shared pointer entity has no member, m has component. What? Oh, it's not a public value. Shit. Oh, that's so cringe. I can't let a bit set be. Oh, you know what? Hold on. I have a better. Now this is gonna be clean. Are you guys ready for this? This is gonna be clean AF. Under the entity manager, auto. This is gonna return a Boolean value. Has component, parentheses. It'll be a const int component. It'll return a bool type. Ooh, we need an entity though. Entity E, comma. Well, I guess we are doing const here too. So if entity type E and const int component, if E dot M has component equals, oh, bracket component, equals false, return false. No, I want to say true. I like it better when it's positive first. If it has component equals true, return true. Else, return false. So that's all you have to do, right? So it'll already check what the component is. And in our case, we're looking to render images. So we care about, let's not even call that. We'll go eman dot control, oh, we gotta save it. So hold on, sorry. Eman dot has component parentheses e comma data. What do we want here? We want a render box, right? Color box, bounding rect. And then do something. No user defined conversion from shared pointer entity to const entity. Oh. God damn it. Standard shared pointer of type entity. Oh, God. Ugh. Disgusting, chat. Disgusting. Fine, don't make it const. Jesus. Wait. Shared pointer. Entity not const qualified cannot be initialized with value type shared pointer entity. What? Ah. I'm planning a re-debut for late September, early October. Yeah, the 3D stuff. Yeah, I saw your 3D model. You showed me that shit. Or at least I've seen it on a stream, maybe? I remember you talking about it. Hey, you guys. Angus the Bus, hello. Dude, watching the Ghostbusters Afterlife movie for the first time in this movie is weird. Yeah, I like the old Ghostbusters, the first one. What a cynical movie. What a mean movie that is. You gotta dereference because shared pointer is still a pointer. Oh. Int? No, not int. How would I dereference a shared pointer? Is it standard? Is it object type? Is that what it was? Is it type? Type T? Underlying type T. That's what it was, right? Bracket, standard. No, just entity, right? That's not it. Type name not allowed? Oh, God. There's something there to dereference what E is, right? I do want this to be const, though. That has to happen. I think this has to be a standard shared pointer entity. So maybe the dereference goes here? Or pointer E. Just use an arrow instead of a dot if you pass in the shared pointer. What the fuck? Why does that work? What the fuck? Oh my God, what is that syntax? I'm used to arrows being like structs. Or like... That is so confusing. Oh, why is there an arrow there? Okay. Well, fuck me. Okay, so now we need to pass this value as a const. So do I just say const auto E? Entity referenced of type entity reference, not const qualified, cannot be initialized with value of type const shared pointer entity. What is this? A shared pointer entity iterator. I'm missing something here. Did that work? Save. No, it didn't. Fuck, shut up. Oh, it worked. I didn't save it. Okay, my bad. Did you not learn pointers? No, I did, but it's just, I'm not used to shared pointers. Like, everything I learned about C++ was without RAII, and just adding shared pointers makes everything so much more complicated. And I understand it's so I don't forget to call the delete value, but fuck me, it sure does seem a lot more simple sometimes to just use new and delete everywhere instead of just calling this shared pointer shit. Not closing the if statement? Yeah, I know. 1, 2, 3. What? Wait, if the, oh, that. Sorry, I thought you meant like the other quotation mark. Okay, my bad. Or the other curly brace. Okay, no warnings, everything's good. Okay, jeez. All right. Okay, next. If this is true, if this entity has this value in the bit set to true, then we're going to be assuming it's true at this point. So, SDL. Oh, I need the renderer. Shit. SDL renderer pointer renderer. SDL render copy XF. No, render copy floating point value. So we need the renderer, the texture to render, which is no, something we need to add as a component because I need a texture. Boom, boom. All right, so let's add it. Let's do the values. So struct C texture SDL texture and then we add it to the end. So texture equals 13. Total components is n+1. Add a standard map int C texture textures, and then here we call, or we add to the case, data texture. Data textures bracket MID dot texture is equal to 0. Break. Paste. And instead of this, we dot erase MID, and then we break. And then down here, textures dot erase MID. So this is what I mean by tech debt. So now I'm done. We've added this to the game as a component. So now it's just there. So if I saved it, we're not testing for bounding rect. We're testing for texture. Something broke. Oh God, what broke? Incomplete type name not allowed. What? Incomplete type not allowed? Oh, I have to initialize it to 0. No, it still doesn't work. Wait, what? Something's wrong. Error type C texture. So, can I not? This is fine though, right? Incomplete type not allowed. I can't have an SDL texture just exist? Wait, what am I doing wrong? I'm off to bed. Have a 10-hour drive tomorrow. Have a good night. Have fun moving. Oh, I'll see you later, Katie Bug. Tell me how it goes. Oh, hell yeah. Does the texture need to be a pointer? Oh my God, you're so fucking smart. Oh my God, how based are you? Does that change anything? I kind of want to make it a shared pointer now, but all right, whatever. We'll ignore that for a second. Come back here, everything's working. So now we're gonna test for texture and then E, no. We have the value. So we need to go to, where do we grab the texture from? It would be data textures using bracket E dot M. Oh my God, I need the MID as a fucking key. Dude, I'm just tempted to make this all public. I guess I could add like a get value function, but that would be a whole nother switch statement. Wrapping raw pointers in shared pointers is not recommended. I mean, you could do it though. We did it when we did our SDL3 tutorial. We wrapped a SDL renderer and an SDL window, both C pointers, in a standard unique pointer wrapper, calling a lambda with standard function in order to delete the pointers when we were done with them. But that was with unique pointers. I don't know how much more difficult it is with shared pointers. Unique pointer does not equal shared pointer. Yeah, I know. Okay, so here's the question. Now that we have our thing here, how do we access the actual values for these? Well, you would need access to the data vectors. The problem is, and I have access to these, that's fine. So that's what this is. Data textures is this map of all values for everything. The problem is the key, the integer value, is a private value. This. So I guess it would be, we could either make this public. It is a const value. Is there any downside to making that public? kind of. It is const though. I mean, is it really that bad for a const value to be public? I don't think so. It is weird that it's called MID, but I think that's probably fine. I think it's probably okay. Okay, so what's wrong here? No suitable conversion from C texture to SDL texture pointer exists. Oh, it's the referenced value. No? Oh, it needs to be dot texture. That's why. There we go. Const SDL rect. So we're gonna do the same thing. If this and texture and we need a bounding rect. Then do the same thing. Data, bounding recs. I'm glad I capitalized that earlier. Using EMID as the key. Dot render rect. SDL rect, SDL F rect. I think this is null pointer here. Then this is a referenced value. Okay, we called it. Oh my god, we actually fucking did it. Holy shit. We actually called the fucking function. Oh my god, that was so verbose. Okay, you can do it with unique pointer because uniques can take ownership. Oh, okay. All right, sweet. And if it doesn't have these values, then don't render the object. Okay, Jesus, that was so verbose. Is there any kind of type def or using value that we can really shorten this on? I guess we could. This is like a good time to use them, right? Because we're going to be calling a lot of systems here. So using emanager dot has component. Oh, I'm doing this backwards. We'll call this has entity has value. eman dot has component, or is equal to easman dot has component. I forget the syntax here. eman dot has component. E, comma. I can't template this, huh? We'll just do that. And E value. Yeah, we'll just do that. What is wrong here? E-man is undefined. Does it need to be defined if we're using a using value? You can template a using. Oh, thank fucking God. Template. Ooh. Template. Type name T. That has component E, comma T. Can I do that? And then now this is. Can I do that? Is that how this works? Using is static. Eman is runtime. Using is a compile, wrong word. So I need a type def. Is that what you're saying? Oh. Why did I think there was an explanation point at the beginning of that? So type def. Eman is once again a render thing. I'm trying to make it so I can call this has component thing, this whole line, as just, you know, one thing. I guess it could have separate using values for all the different kinds. So instead of eman.hasComponent, I can be like, well, this works, right? No, it doesn't. Yeah, identifier eman. You can't use eman at all using using or type def. Fuck me. So I guess I could help. You guys can help me here. How do we shorten this syntax? I guess I could just get rid of this entirely and just live with the eman dot here. No function definition for has component. Oh my God. You would want a helper function? Is that sounds like a lambda. That sounds like a lambda if I've ever heard it in my life, in which case I have lost interest. I thought a whole point of typedef was like to have a preprocessor. Can I just make a macro? Is that illegal? Can I just macro this shit? There must be I bet I can macro this. Not necessary. We'll keep it like this for now. We'll keep the verbosity, but I would love a way to be able to just call, like, you know, this and just return the values, you know, but we'll stick with the verbosity for now. All right. Is that it for rendering images? It just iterates through every entity. It does not. Does it matter if it's alive or not? Do I care? If it's an entity on the entity vector, it is only removed at the beginning of the frame. I guess that's fine. It would just exist for one frame, even after it may die, but it'll die the next frame. I guess that's fine. Lambdas aren't necessary. You can use a regular function. We'll worry about it later. It's something we can fix later. It's fine. Okay, so now we can render images, and that's all we have. So did we start our game loop? I just want to see if we can even render something, because we've done so much and we haven't tested this shit at all. And I feel like it might be time to call the main game loop here. Yeah, I think it's time. So file, save, add module, game loop. Boom. We are going to be calling it a module interface. We're going to import, do we need SDL? Do we need SDL at all? Yes, because we're going to use it for input. We do need the SDL library. Okay, import the standard library. We're going to import systems. Do we need to... Where do we call? Wait, am I skipping the gun? Am I jumping the gun? Should we be calling like a load game module to actually load all of the assets for our game? Oh my God, I know what I'm doing tomorrow. Oh no, I know what we're doing tomorrow. Chat, we're gonna make our own custom iStream. Holy shit. You guys ever mess with iStreams before and not .xml files? Because that's what we're fucking doing tomorrow. Basically, I want a notepad file that contains like information for what we need, and then read off of that as like the loading game system. And that's where we're gonna have everything. And we might as well just start now. Fuck. Okay, don't save it. Okay, we'll do that. Solution Explorer, and then we'll just delete the game loop. Delete. Okay. All right, here's where we're at, chat. We did a lot today. We're done with entity and components for now, assuming it works. At this point, we are tomorrow going through iStreams, reading a super basic notepad file with like not easy to read syntax, just so we can get started on it. And then render a player character. Luckily, input's gonna be the easy part, because I've done that like 20 times with SDL. So taking input, moving the character, using a system where if we press left on the keyboard, then subtract X position from the fucking whatever. We're gonna have a move position system. So that'll be something we implement for the first time. And then we mess around with movement. That's gonna be the goal tomorrow. Notepad file. I stream to interpret the notepad file. What else? A lot of stuff. System, movement, all that shit. That's gonna be tomorrow. Tomorrow, hopefully, finally, we have a fucking prototype after all this delay. A week delay. Holy shit. That's gonna be the plan tomorrow. All right. Let's come here, chat. Time to make an AST. Oh, I never did an iStream before, so it's gonna be a fun learning experience together, chat. After all, what's the point of XML if you can't do it in C++ first? All right. Have a good night. Have a good evening. It's gonna be fun. It's gonna be great. I'll see you tomorrow. Probably an IRL stream, but we'll see. All right. See you later. Goodbye.